Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video, I will be solving the paper 2 exam for October-November 2019 variant 1. So let's get started. Question 1 says a student measures the diameter of a pencil. Which measuring instrument will give the most precise reading? So a measuring tape, a meter ruler, these have the same scale, centimeters and millimeter. So no. Micrometer, screw gauge, yes. A ruler again has the same scale, so the answer here is C. Question 2 says a light object is dropped from rest. It falls a large distance vertically through air. How can the motion of the object be described? Is it constant acceleration, increasing acceleration? That would be impossible. Decreasing acceleration and then moving with terminal velocity. This would happen if there is air resistance, and this would happen if there is no air resistance, but it said through air, so we choose C here. It is not increasing acceleration, it is decreasing acceleration, then constant velocity or terminal velocity. Question 3 says a car travels at an average speed of 60 kilometers per hour for 15 minutes. How far does the car travel in 15 minutes? So distance is equal to speed multiplied by time. If the speed is 60 and in kilometers per hour, we need the time to be in hours. So we divide the 15 minutes by 60 to convert from minutes to hours, and that would give an answer of 15 kilometers, so we choose B. Question 4 says which quantity is a force due to a gravitational field? That would be the weight, so the answer here is C. Question 5 says the density of air is 1.2 kilograms per meter cubed. A room has dimensions 5 by 4 by 3 meters. What is the mass of the air in the room? So the mass is equal to the density multiplied by the volume, and we have the density 1.2, and the volume can be calculated by multiplying all these dimensions by each other. So 5 times 4 times 3, that gives an answer of 72 kilograms, so we choose D. Question 6 says a car is traveling around a circular track at constant speed as shown. In which direction is the resultant force on the car? So for any object moving in a circular path with constant speed, the force is towards the center of the circle, so we choose B. Question 7 says two forces P and Q act on a meter rule as shown. The meter rule is pivoted at one end. The rule starts to rotate in a clockwise direction. Which statement is correct? So for the clockwise moment to be greater than the anti-clockwise moment, P times A should be greater than Q times this whole distance, which is A plus B. So P equals Q, no. P is less than Q, no. P times A is equal to Q times B, not B, and it is not equal. P times A greater than Q times A plus B. Yes, that is what we just said, so the answer here is D. Question 8 says which statement gives a complete description of any object that is in equilibrium? There is no forces acting. No, there may be forces but cancelling each other. There is no resultant force. Yes, there is no resultant force and no resultant turning effect. That is the double condition for an equilibrium. So there might be no resultant force, but there may be a resultant moment. So B is an incomplete sentence, but C is the complete sentence. So we choose C. Question 9 says two objects X and Y move directly towards each other. The objects have the same mass. Object X has a velocity of 5 meters per second to the right. Object Y has a velocity of 3 meters per second to the left. Object X and Y collide and stick together. What is their velocity after the collision and in which direction? So using the equation m1u1 plus m2u2, the total initial momentum is equal to m1v1 plus m2v2, the total final momentum. The initial momentum of object X is mass m multiplied by 5 and minus, because it is in the opposite direction, the momentum of Y. So another mass m multiplied by 3. And at the end, both masses move with the same velocity, so 2m have the same velocity, no v1 and no v2. There is a common velocity v unknown, and we can divide by mass in the whole equation, so m is removed from this. So 5 minus 3, which is 2, is equal to 2v. So v is equal to positive 1, and we choose the 5 to be the positive and the 3 to be the negative, and 5 was to the right. So the answer is to the right, and the value is 1 meter per second. So we choose B. Question 10 says, brakes are used to slow down a moving car. Into which form of energy is most of the kinetic energy converted as the car slows down? So the brakes use friction, so friction causes heating effect, so thermal energy. So the answer is C. Question 11 says a man carries 20 tiles from the ground to the roof of a house. Each tile has a mass of 1.2 kilograms. The roof of the house is 15 meters above the ground. How much work does the man do against gravity on the tiles in carrying them to the roof? So the energy or the work done is the change in gravitational potential energy, so mgh, and then we multiply by the number of tiles. So the mass is 1.2, g is 9.8, and the height was 15 meters. And then we multiply by 20 tiles. That gives an answer of 3,528 joules, which is approximately 3,600 joules. So we choose D. Question 12 says a car is moving along a straight horizontal road. The car has 1.6 megajoules of kinetic energy. The car accelerates for 20 seconds until the kinetic energy of the car increases to 2.5 megajoules. What is the minimum average power developed by the car engine for this acceleration? So power is equal to the change in energy over the time, or the work done over the time. And that change in energy was the difference between 2.5 and 1.6. But for megajoules, we multiply by 10 to the power of 6, and then we divide by the time, 20 seconds. That gives an answer of 45,000 watts. So the answer is 45 kilowatts. So we choose C. Question 13 says a drawing pin has a sharp point at one end and a flat surface at the other end. The pin is pushed into a wooden board. How do the pressure and the force at the sharp point compare with the pressure and the force on the flat surface? So for the force, it is the same force. Solid objects transfer the force as it is, so the same as on the flat surface. And the pressure at the sharp point would be greater than on the flat surface, so greater here and here. So the common choice here is C. Question 14 says an object is 20 centimeters below the surface of a liquid. The density of the liquid is 1,200 kilograms per meter cubed. What is the pressure on the object due to the liquid? So pressure is equal to rho GH, the density 1,200, and G is 9.8. And then we have the depth. 20 centimeters is not accepted, so we divide by 100 to convert it into meters. That gives an answer of 2,352, which is approximately 2,400 Pascal. So we choose B. Question 15 says which statement about the evaporation of a liquid is correct? The least energetic molecules escape. No, not the least. It is the most energetic molecules. Escape from the surface and the temperature of the liquid decreases. Escape from the surface and the temperature of the liquid increases. Not increases, it decreases, because evaporation causes a cooling effect. So the answer here is C. Question 16 says a bubble of gas is formed deep underwater. The bubble has a volume of 40 centimeter cubed, and the pressure inside the bubble is P. The bubble rises up through the water. The volume of the bubble increases to 56 centimeter cubed, and the pressure becomes 100 kilopascal. The temperature of the gas does not change. What is the initial pressure P? So we can use the equation P1V1 is equal to P2V2. So P multiplied by 40 is equal to 100 kilopascal multiplied by 56. Then we divide by 40 on the other side to get P. That gives an answer of 140 kilopascals, so we choose D. Question 17 is removed from the syllabus because it is about thermometers, so you can skip this question. It says which change in the design of a liquid and glass thermometer makes it more sensitive? Larger liquid reservoir, yes, because it increases the amount of expansion. Longer tube, no, that affects the range. Smaller liquid reservoir, no, that would decrease sensitivity. A wider tube also decreases sensitivity, so the answer is A. Question 18 says a liquid turns into a gas. This occurs only at one particular temperature, and the change happens throughout the liquid. What is the process called? Boiling, condensation, evaporation, or fusion. So it is either boiling or evaporation, the change from liquid to gas. But since it is at a specific temperature and through the whole liquid, it is not evaporation, it is boiling. So we choose A. Question 19 says one end of a rod of copper is placed in hot water. Thermal energy travels along the rod to make the other end warmer. What is the behavior of the copper at an atomic level that accounts for most of the transfer of thermal energy from one end to the other? Atoms at the hot end gain kinetic energy and move. Atoms do not move in solid objects. Atoms at the hot end expand, colliding with the other atoms. The volume of the molecule itself does not increase. The spaces between molecules increases. Free electrons at the hot end gained energy and moved towards the other end, colliding with atoms along the rod. Yes, Free electrons at the hot end gain energy again from the hot water and move directly to the other end. No, they collide with atoms on their way to the other end. So the answer here is C. Question 20 says a surface is made so that it is a good source of infrared radiation. Which surface is not suitable? So we needed to emit radiation more. So painted matte black, yes. Painted white, no. That is heated at high temperature, yes. Surface that has a large surface area, again, yes. So the one that is not suitable is B. Question 21 says a large hill blocks the direct path between a transmitter of radio waves and the receiver as shown. The receiver picks up the signal from the transmitter even though the radio waves do not travel through the hill. Which row is correct? So not traveling through the hill is not refraction. So refraction would be the change in the medium from air to the hill to air again to the receiver. So it is not talking about refraction. It is talking about diffraction around the hill. And diffraction happens the stronger when the wavelength is large compared to the band. So longer wavelength, not shorter wavelength. So we choose A. Question 22 says the diagram shows the image of a clock in a plane mirror. What is the actual time? So there is a simple trick for the images in a mirror. You just, for a clock, instead of numbering the time clockwise, you number it anti-clockwise. So starting from 12, we go 1 anti-clockwise, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So the hour arm is pointing towards the 7 and the minute arm is pointing toward the 3. That's 15 minutes. So it is 7:15. So the answer is C. Question 23 says a converging lens produces an image of an object O. The focal length of the lens is F. Which position of the object produces a virtual image? That would be between the focal point and the center of the lens. So it should be at a distance less than the focal length. So the answer is A. This is the focal point and this is the center of the lens, and the object is between these 2 points. Question 24 says the diagram shows electromagnetic spectrum. A word is missing from the label below the spectrum. So this is the direction of increasing what? It is not amplitude and it is not speed. It should be either frequency or wavelength. So going from gamma rays to radio waves, the wavelength is increasing and the frequency is decreasing. So this is increasing wavelength. Question 25 says which row gives a possible set of values for the speed of sound in ice, water, and steam? So that's solid, liquid, and gas. So in ice, solid, that would be the highest speed. In water, it would be moderate. In the middle, 1,500. And in steam, like air, that would be in terms of hundreds. So the answer here is D. Question 26 says a steel bar is placed in an east-west direction for it to be demagnetized. No other magnet is nearby. Which method is not suitable? So hammering the bar would work. Heating the bar to a very high temperature would work. Slowly take the bar out of a coil that carries an alternating current. That would work. Slowly take the bar out of the coil carrying a direct current. That would create a strong magnetic field. It helps magnetizing the bar, not demagnetizing the bar. So the answer is D. This is the one that is not suitable. Question 27 says a plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Why has the rod become positively charged? It has gained electrons or gained neutrons. No, not neutrons. And lost neutrons, again, not possible. For becoming a positively charged object, we lose electrons, not gain electrons. So the answer here is C. Question 28 says a circuit contains a cell of electromotive force 2 volts. The current in the circuit is 2 amperes. How much energy is converted by the cell in 2 minutes? So we have voltage, current, and time, and energy can be calculated in a circuit as VIT. So the voltage is 2, current is 2, and the time is 2 minutes, which we should convert into seconds. So we multiply by 60. That gives an answer of 480 joules. So the answer here is D. Question 29 says the circuit diagram shows a cell connected in series to a resistor and a component X. What is component X? That would be a diode, so the answer is B. Question 30 says identical resistors are connected together to form arrangement X, Y, and Z. What is the correct order of resistances of the arrangements from largest to the smallest? So if we consider the resistance of each resistor to be R, so this would give a value of 0.5 R. Any 2 identical resistors connected in parallel would have half of one of the resistors, or we divide the resistance of one resistor by the number of resistors in parallel if they are identical. And for Y, that would be R plus R, so 2R. And for Z, we have R plus R plus R, that would be 3R. So from largest to smallest, largest is Z, 3R, and the smallest is X, which is 0.5 R. So from Z to X, so the answer is D. Question 31 says a circuit contains a cell of electromotive force 2 volts, 3 resistors, 3 ammeters, and 2 voltmeters. 1 ammeter is labeled P and 1 voltmeter is labeled Q. The readings on the other 2 ammeters and the other voltmeter are shown. What is the reading on ammeter P and the reading on the voltmeter Q? So the total current was 2 amperes passing through this resistor, and this current splits into 0.5 ampere on the upper branch. So the rest of the current would go into ammeter P and the resistor on the bottom. So to get the current, we subtract 2 amperes minus 0.5. That gives a reading of 1.5 amperes for P. And as for the voltage in series connections is divided. So part of the voltage of the 2 volts of the battery, 0.5 volts on the left side, that would leave the rest of 1.5 volts on the right side. So this section would take 1.5 volts. And in parallel connections, there's no division of voltage. So the upper branch takes 1.5 volts and the lower branch also takes 1.5 volts. So Q would take 1.5 volts. So the answer here is A. Question 32 is about logic gates. So you can skip this question for the new syllabus. It says there are 2 inputs and 1 output for the combination of logic gates shown. Which truth table represents the operation of this combination of logic gates? We have the choices of the inputs 0, 0, 0, 1, 1, 0, and 1, 1. So we try them in turn. So for 0, 0, 0 through a NOT gate, that gives 1. And 1 and 0 through an AND gate, that gives a 0. For 0 and 1, we have 1 converted to 0 through the NOT gate. 0 and 0 gives us 0 through an AND gate. Now 1 and 0, 0 is converted to 1 through the NOT gate. So 1 and 1 through an AND gate, that gives us 1. And the final choice, 1 and 1, 1 through a NOT gate, that gives us 0. 1 and 0 through an AND gate, that gives 0. So going this way, 0, 0, 1, 0. So we have this 1, 0, 0, 1, 0. So the answer is B. Question 33 says, where must a fuse be connected in a mains electrical circuit? Is it on the earth wire only, live wire only, neutral wire only, or live wire and earth wire? That would be live wire only, so we choose B. Question 34 says, a student investigates the output voltage induced across a coil of wire by a bar magnet. When will the induced voltage have the greatest value? The student slowly moves the bar magnet into the coil of the wire, not slowly. The student leaves the bar magnet stationary in the coil, that will not induce any current. The student quickly removes the bar magnet from the coil quickly and there is motion, so yes. The student places the bar magnet at rest, again stationary, no induction. So the answer here is C. Question 35 says there is a current in a wire. The direction of the current in the wire is out of the page. Which diagram shows the magnetic field pattern produced? So we have concentric circles, so it is not C nor D. And the field lines should always be in the same direction, so it is not A. So the answer here is B. Question 36 says diagram 1 shows a coil of wire P between the poles of a magnet. The ends of coil P are connected to a battery by slip rings. Diagram 2 shows a coil of wire Q between the poles of a different magnet. The ends of coil Q are connected to a battery by a split ring commutator. What happens to coils P and Q? So continuously turns clockwise or anti-clockwise and makes 1/4 turn or continuously turning. So first, to know the direction of rotation, we use Fleming's left-hand rule. If the magnetic field is pointing to the right, the index finger is pointing to the right. And for the current moving from the positive terminal, so the current would be on this side into the page, and the middle finger should be pointing into the page. The thumb is pointing down, so the force on the left side is down and on the right side is up. So this causes a rotation of anti-clockwise direction. and the current on the right diagram or diagram 2, again going into the page on this side. So the force is downwards on the left and upwards on the right. Again, the rotation is anti-clockwise, so any clockwise answer would be rejected. So not clockwise, not clockwise, not clockwise, not clockwise. So B and D are rejected. For the slip rings in a motor, that would cause a quarter rotation and then it will stop or will go backwards. For a split ring commutator, it will keep rotating in the same direction. So continuous rotation for Q and quarter rotation for P. So the answer is C. Question 37 says, which diagram shows a possible structure of a neutral atom? We have the black circle proton, white circle neutron, and the small gray circle electron. Electrons are not in the nucleus, so it is not B nor C nor D. Electrons revolve around the nucleus, and inside the nucleus we have neutrons or protons, so the answer is A. Question 38 says, the scattering of particles by a thin gold foil provided scientists with evidence for the nuclear atom. Which particles are scattered by the gold nuclei in the thin foil? This is called the scattering of alpha particles, so we used alpha particles. So the answer is A. Question 39 says, the diagram shows beta particles being directed between the poles of a magnet. In which direction will the particles be deflected? So the magnetic field is from north to south downwards, and the current is always opposite to the direction of beta particles because they are negatively charged. So the current is to the left. Using Fleming's left-hand rule here, we have the current to the left by the middle finger and the index finger showing the direction of the magnetic field. The thumb is pointing out of the page, so we say out of the page is the answer, so we choose B. Question 4 says, why are some radioactive sources stored in boxes made from lead? Is it because lead absorbs emissions from the radioactive sources? Yes. Lead decreases the half-life. Nothing decreases the half-life. Lead increases the half-life. Again, no change to the half-life. Lead repels emissions. No, there is no charge in the lead atoms themselves. They are neutral. So the answer is A. And this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing, and I will see you in another video.